In fact, the government comes to me and asks for help, cooperation, and I see that very favorably. I think they're simply baffled, they're not clear about what these objects are, and it's a mystery. So as soon as they approached me and asked me to lead the UAP Science Advisory Council, they had me at hello. So this is very significant because it's the first time that the government comes out and asks for advice from scientists. I then had to establish a forum that includes some of the most credible scientists working on this subject.
The administration has released around 400 unclassified documents. Are any of them can count as proof or evidence of alien life?
It's clear that the mainstream of the intelligence agencies, the Pentagon, take it seriously because there is data from sensors that you cannot deny. So what does it tell you? It tells you they think that it may not be human-made.
Yeah.
Right? I mean, there was for many years a taboo on discussing them, a stigma, and that is an important aspect because the mainstream of the scientific community is still reluctant from discussing it. There is a new paper that we just completed. I cannot give a lot of details because it's now being still refereed, but it gives clear evidence that we're dealing with materials from outside the solar system.
But what will be the strategy and what do you hope to find?
So I hope to...
The administration has released around 400 unclassified documents. Are any of them can count as proof or evidence of alien life, in your opinion?
Well, one interesting aspect of this, first of all, it changes the narrative of the discussion because now it's clear that the mainstream of the intelligence agencies, the Pentagon, take it seriously because there is data from sensors that you cannot deny. It's not just hallucinations, and it's not just optical artifacts. It's real objects that they are unable to figure out. And at the very least, if you are down to earth in your interpretation, you would say, well, these are human-made technologies, in which case we are dealing with something the US government cannot identify, meaning it's a national security threat. These could be technologies that we are not aware of, that adversarial nations are using, and therefore we should look into that more carefully. But instead, he's releasing it to the public. And during the same week, asking me as a scientist to help them establish a science advisory committee. So what does it tell you? It tells you they think that it may not be human-made, right? I mean, that's the only reason they should ask for an outside scientific opinion. And so that's very exciting. And for me, of course, as soon as they approached me and asked me to lead the UAP Science Advisory Council, they had me at hello, so to speak, and I then had to establish a forum that includes some of the most credible scientists working on this subject. There aren't many, but there are lots of people that have opinions on the internet, and that's not the kind of conversation I want to have within this council. We will basically ask for scientific data, so that we can figure out the nature of these objects. And if such data doesn't exist, we would encourage the Pentagon to collect new data. Because the only way to figure things out is like in a detective story. You need to get enough clues that will guide you towards the truth. It's not a question in philosophy. We're dealing with objects and we need to figure their nature, right? So first of all, it's not good practice for organizations to hide things from the public, because eventually nobody is forbidding us from looking up, and such data will be collected by private citizens, like also the Galileo Project that I'm leading. So it really makes no sense to hide information about what lies outside the solar system, cosmic questions, whether we have a neighbor. The second thing that you learn from that is nobody put the Pope in jail. Nobody took the bureaucrats of the Vatican and said, we should punish you because you've hidden information from the public for centuries in their case. And by the way, the amazing thing is, now we know after, in 1992, they announced that Galileo was right. The same year, there was the Cosmic Background Explorer satellite, the COBE satellite, that revealed the early fluctuations in the cosmic microwave background that led to the structures that we see today in the universe. So that led to the formation of galaxies like the Milky Way, inside of which stars like the sun formed, and around which there was debris left over that made planets like the Earth. So we understand how we came to exist, right? But it turns out that the Earth formed only in the last 1/3 of cosmic history for 9.4 billion years. There was no Earth in the universe. So obviously the Earth cannot be at the center of the universe because it didn't exist for 2/3 of cosmic history. But moreover, after it formed the Earth, it orbited the sun 4.5 billion years.
Yeah.
So that was before the Vatican started arguing that the sun moves around the Earth. So just think about the situation where the Earth didn't exist for 2/3 of cosmic history, then it moves 4.5 billion times around the sun, and then comes the Vatican and says, no, the sun moves around the Earth. Who cares? It really, on cosmic questions, authority doesn't matter, right?
Yeah.
So we need to find the reality that we live in the context of unidentified objects, is whether we are being visited by some alien technological civilization. And it's for the benefit of all of us to recognize it and then adapt to it. Nothing dramatic happened when humanity adapted to the notion that the Earth is not at the center of the universe, and I think the same would happen here. It will be an ontological shock because we would not be at the top of the cosmic food chain.
Yeah.
Right? So we would realize there might be more accomplished siblings to our family of intelligent civilization. But thinking that God is a parent that can attend to only one child is really limiting. And I think it will change, of course, our perspective about our existence, but also about our aspirations for the future.
Wow, of course. Okay, so you touched on many topics which are, I want to dive into most of them if we could manage, the creation of the galaxy and everything else. But first of all, let's just give you a proper introduction for some people who may not know you. You are Professor Avi Loeb. You are a world-renowned astrophysicist from Harvard and one of the leading voices in the scientific search for extraterrestrial life. We are here at your home in Boston, so thank you again for having me. This is an amazing experience. So I want to dive into what you said, but let's start with this UAP forum that you are assembling. First of all, how big is it of an event for you and your career? So how big of an event is it?
This is very significant because it's the first time that the government comes out and asks for advice from scientists. Also, it comes together with a disclosure process. And Steven Spielberg on June 12th came out with his film Disclosure Day.
Yeah.
And I went to see it on the same day, but a few hours earlier, the third batch from the US government was released, and that was the real disclosure. And it looks very different than on the movie screen, of course, because on the movie screen you see the car of those who are trying to disclose information from government. The car is being crashed against a moving train, and nobody is trying to crash my car against a moving. In fact, the government comes to me and asks for help, cooperation, and I see that very favorably. And I think they're simply baffled. They're not clear about what these objects are, and it's a mystery. So I think it's very significant because it brings the subject, like any other puzzle in physics, to the attention of scientists. We will try to get better data, either if it exists within government or if it needs to be collected in the future. The point, you may ask, why would the government be the first to discover something new, in the sky? And the answer is because astronomers are focusing usually on small portions of the sky at any given time. They ignore objects that fly overhead. The government has to do that for national security purposes. Then you might say, okay, well, the government does not care about science. They care about practical matters, threats from other nations.
Yeah.
And how come they would bring up to the attention of scientists something new? And the answer is they did it already. Back in the late 60s, there was a program to build the satellites that would monitor the Soviet Union potentially exploding nuclear weapons above the atmosphere. It was called VILA, the VILA program. And the idea was to detect gamma ray flashes in high energy photons, radiation coming from nuclear explosions above the atmosphere. There was a ban on such things, and the US wanted to monitor to make sure that the Soviets are really following the agreement, the treaty that agreed on no nuclear explosions.
Yeah.
And then they started seeing every day or two a gamma ray flash. And I'm sure at first they were alarmed, but eventually they realized it's coming from the universe. And then in 1972, they published a paper from Los Alamos, a group there, saying, oh, there seem to be gamma ray bursts coming from the universe at large, and we don't know what the origin is. And initially, the astronomy community decided, well, it requires a lot of energy for these explosions if we were to put them at cosmological distances. So let's just keep them within our Milky Way galaxy, because then you don't need as much energy. Then perhaps neutron stars can accommodate flares like that. But turns out that in 1997, there was an Italian-Swiss satellite that discovered X-rays coming from the same events, not just gamma rays. And then they could localize it and see that these events are originating in galaxies very far away, at the edge of the universe. So then it was realized, actually, these explosions are huge. They are the biggest explosions in the universe, releasing often more than exploding stars, supernovae. Turns out that these are the flags of the birth of black holes from the collapse of the core of massive stars.
Wow.
So the long duration gamma ray bursts originate when the core of a massive star consumes its nuclear fuel, and then it starts collapsing as a result of its self-gravity. And in the process of going down the drain, like water goes down the drain, it's circling around, there are jets being produced of material that moves close to the speed of light. And these jets drill a hole in the envelope of the star, and if you happen to lie along the axis of the jet, you would see it as a gamma ray burst. And so that's one process for producing them. There is a second process of two neutron stars colliding, producing a gamma ray burst, but that usually produces a short burst, less than 1 second. The long duration bursts that are more than a second are associated with black hole formation. So here is an example. The US government discovered, as a result of a national security concern, they made a discovery about the cosmos. So give them that credit. And then more recently, I realized that a catalog by NASA that was compiled by data from US government satellites did discover meteors. These are objects colliding with Earth and producing a fireball that originated from outside the solar system. These were objects moving too fast to be bound by gravity to the sun. And the first one was recorded back in 2014. And I went on an expedition to retrieve materials from this interstellar meteor. And that's another discovery that was made, in my opinion, by the US government. Very recently, on April 1st, 2026, there was another one that we flagged in the NASA data set. And in between those, there were a few other candidates. So in my view, the US government made two important contributions to science without even seeking it. In the case of those fireballs, they were just looking for the flares from the launch of ballistic missiles. So these are the same satellites looking at Iran, during the war. And so the point is, out of a national security interest, they happen to discover things.
What is exactly in this? How do you call it even, the forum, first of all?
It's a UAP Science Advisory Council.
Okay. Yeah.
So basically, we're focusing on science, trying to encourage the government to get scientific quality data, because a lot of the data that was released doesn't have information about the distance of objects, the context, or the intelligence interpretation of what really happened there. Even if they cannot figure it out, they should tell us what they're thinking. There was some information that was redacted also.
What will you and those people, if you can tell who they are, would be amazing. But what will you be exposed to
So I selected a group of 14 people so far, and we are 15 people altogether. And the group includes a few nerds. These are young scientists that I brought in because they have expertise in artificial intelligence. They think differently. They don't have a baggage, and I want them to be independent thinkers because there are lots of people who have opinions about historic events, about the data that was collected over the years. But it's really important to have young people as well. And then in addition to that, I brought experts that have expertise in physics, in oceanography, in human psychology, because these unidentified anomalous phenomena are reported by humans and interacting with humans. There is also the aspect of how society responds to those reports. I mean, there was for many years a taboo on discussing them, a stigma, and that is an important aspect because the mainstream of the scientific community is still reluctant from discussing it. So there is definitely a psychological element to the way we are interacting, reacting to it, and I brought two people with expertise in psychology. And then I have also a communication officer because we need to communicate what we find to the public. And material science experts as well. So I chose a variety of expertise that will make this council effective. And in terms of the size, I didn't want it to be too small because then it's sensitive to the voices within a small group. And then also a small group doesn't have all the expertise. But a group that is too large, by the central limit theorem of statistics, will regress to the mean, meaning that all of its conclusions will be boring. According to the central limit theorem, the deviations from the mean scale inversely with the square root of the number of voices. So
you see it in governments and everything.
Yeah, like so I don't like large committees because then by consensus, the committee is not innovating, is not finding something exciting.
I think another person that should talk to you is Steven Spielberg, perhaps, because this sounds like an amazing movie.
Oh yeah, I think actually reality is far more inspiring. I think than what Steven imagined. A decade ago, I met him when he got an honorary degree at Harvard, and I told him about my research, and he said, Avi, if you find evidence for aliens, please let me be the first one to know. And I think the reason that he said that is because he recognizes that nature is far more imaginative than even the best script writers in Hollywood. And you might ask why? Because everything that is written by humans is based on a training data set that is limited to this Earth, whereas something that visits us from far away has a much bigger data set to attend to, and most of the real estate is beyond Earth.
I heard you say a couple of times, actually, that perhaps the dimension of which they will contact us perhaps will not even be physical, and we will not be able to see in our eyes the things.
Yeah, that's quite possible because our physics and technology is limited to 1 century so far after we discovered quantum mechanics. All the gadgets that we use, that we're speaking into right now, are based on our understanding of quantum mechanics a century ago. And just imagine how more advanced we will be in 1,000 years, 1,000,000 years, 1,000,000,000 years, and they may represent our future. So now this brings in an important caveat to the search that we make, because maybe they are behaving in ways that we cannot really easily detect.
Of course.
Also, in terms of communication, if they are so much beyond us, it will be difficult for us to understand what their intentions are.
I don't think we should even give them the superiority as a given. Perhaps it's just different species.
Yeah, it could be very different.
Just different.
Right. It could be that there is a gap in terms of the age of the civilization, which is very natural, given that the age of the Milky Way galaxy is 10 billion years, and that compared to the age of humanity, which is 10,000 times shorter right? So if they survived, of course, there is a question of self-inflicted wounds that a civilization might have a finite lifespan.
Yeah.
But there is the Darwinian principle of the fittest survive. So all these civilizations that were killing each other and they perished on their planet because of wars, they are not around, right? Yeah. So the ones that we will meet, first of all, had to survive for long periods of time. Second, had to venture into space. And they would be remembered in the history books of the Milky Way galaxy for that reason. Whereas the ones that stayed on their planet, killed each other, or fought over, it was obvious to them that they have to invest all the resources in down to their exoplanet matters. Like many people here are saying, we should not explore space. There are lots of people who are poor, and therefore we should just focus on what happens on this rock that we live on. Well, that's legitimate and it sounds completely reasonable, but if you think about long term, that's not a good idea. Because, a billion years from now, all liquid water on the surface of Earth will be vaporized by the sun getting brighter, and if we get there, yeah. And then 7.6 billion years from now, the sun may engulf the Earth, and then we would be driven to the center of the sun, where we will end being part of a white dwarf relic. So that's like the corpse of the sun. So my point is, what are we investing in? Something that will never stay around, for very long, billions of years. That's the unit of time in the universe. Sorry to say, it's not decades, it's not centuries, it's actually billions of years. So if we are thinking long term, we have to focus on venturing to interstellar space, not to another rock that we call Mars. That's not very ambitious. As much as it sounds amazing to dream about going to the moon or going to Mars, these are just rocks that happen to be near us with conditions far worse than we have on Earth. So the real ambition should be to build a spacecraft that can accommodate humans or our descendants. We might employ synthetic biology to produce superhumans in the future. Right now, we are developing AI, artificial intelligence, out of silicon chips. So we take sand and refine it to make the chips of our computer systems that end up having intelligence that may supersede ours. But I think this is just the first revolution that we will encounter. If we survive that, in the more distant future, we'll realize the human brain is using only 20 watts to have cognitive abilities similar to our AI systems right now that use gigawatts. And so clearly biology solved the problem very differently than silicon chips. And we might develop synthetic biology that can produce a brain more capable than the human brain. Course, yeah. So that will be the next revolution. And then we can send astronauts based on biological brains that were produced synthetically. And you can imagine visitations by such astronauts from other civilizations. They were not the original biological creatures that were sending these things, but they were some modifications that ended up being more capable. Wow. And so we can do the same and send our descendants, but this is clearly worthwhile thinking about more than just investing $2.4 trillion a year in military budgets worldwide. By the way, 1% of the military budgets worldwide goes to science, which is really ridiculous.
This is ridiculous, yeah. I want to go into your thoughts about the universe itself and the scientific community itself, which we discussed before, and it was very enlightening for me. But you said something that I want to stay on for a moment. Do you think that whatever civilization is out there are subject to the same Darwinian evolution biology stuff like us?
No, I think it has to do with whether they can learn how to survive long term. Okay, so we learned how to survive maybe over millions of years, but it's not clear that we will survive much longer than that because we are developing the means for our own destruction.
Yeah.
The real danger right now is, yes, we are on a trend of making our life better over time, and everyone says now, medical healthcare and everything is so much better than it used to be a century ago. So on average, we are doing much better. That's true. But also we develop tools that, if you imagine fluctuations up and down, some bad actors using them for bad actions, whereas others are using them for good purposes. The fluctuations around the mean become bigger and bigger because the tools like AI can destroy whole systems in a much more, and basically prevent the society from a stable future, because a kid in a basement might actually hack an AI system given the open source models that are out there. And given that, there is a bigger risk as we develop better tools. There is or AI systems, that there is a bigger risk for our future. And what I mean by Darwinian selection is that the civilization manages to mitigate the risk as it make advances in technology. So it's not just technology getting better, but it's also being wise enough not to be engaged in this primal effort. Most of the action, most of the real estate, most of the important things are beyond the planet that you're born on. Okay, so and so far, when we talk about space exploration, we are thinking about rocks that are worse than Earth. Happens to be nearby. This is not a good idea. It's like being in the jungle, okay, and then one of the chimpanzees looks around and says, "Oh, here is another tree that we can go to," and turns out that it has fewer bananas on it. What's the point? So, but that seems like very visionary. The chimpanzee that told the tribe, "Here is another tree," is regarded as a person that is worth $1 trillion. Okay, but that's not very ambitious. What you want to do is be the chimpanzee that says, let's go beyond the horizon, because maybe there is something. And then once you go beyond the horizon, you realize it's not all about bananas. There is something completely different going on.
But just sorry for being, I just want to be precise, because the question I'm coming from is like, you give this example, which is brilliant, and it's exactly the same, which chimpanzees, or let's say Homo erectus, I think it was pressed by the nature to leave the trees, right? So this is usually...
Well, we will be, as I said, because of the sun, but also because of self-inflicted wounds at some point. But my hope, I have another solution, which is if we realize that we're being visited by someone who already reached that future, then it will educate us about what we need to do. Because then you realize, it's possible to actually travel to other stars. There are technologies far more advanced than we currently possess. We should be, first of all, humble, and then recognize that we have a way to go, rather than being obsessed with the current situation that we're in, rather than with very superficial comments on social media. That's not really the life that you should aspire to have. It's actually thinking about the cosmos, and that's what happens when a neighbor knocks at your door. Usually within the house, the family members are arguing with each other. There are loud arguments, and then suddenly, when neighbor knocks on the door, everyone becomes silent, quiet, because there is this change of perspective. You realize, there is someone else out there. We should behave. And also, if you end up realizing that when you open the door that this someone is far more advanced, then you are becoming jealous that there is an unknown sibling to your family or species or intelligent civilizations in the universe that you can aspire. It's a better role model for us, And once we recognize that, of course, that will change our priorities. So my hope is that this process by itself would be far more effective than us recognizing, maybe we should change our behavior. I don't think it will happen. I think if you just look at politics on a day-by-day basis, it's very different than what we hope to have.
It comes even to the idea that you said before about how we are, we won't be here for long. If you see the news, it as well.
Right.
But also, I just want to first of all, thank you for all this information and elaboration. It's fascinating, and thank you so much. I want to go into, if it's okay, to the scientific community before we go into black holes and galaxies and
anything.
Stuff. We discussed before about Neil deGrasse Tyson and Brian Cox, which last time you gave them a criticism which you basically said that they are not valid, credible source of science.
Well, they're not practitioners. So I call them the Kardashians of science. The way to define them is as influencers. So what is the role of an influencer? Is someone that wants to be liked by a lot of people and then influence their views about, in this case, science. So they are speaking the language of how would I appeal to a large community, large audience, while at the same time going with the flow of the scientific community. The problem is that sometimes the scientific community is going in the wrong direction. Just consider Brian Greene, that was advocating for decades string theory, which is now in bad shape. Everyone recognizes that because of the reasons that were pointed out early on, but he completely ignored them and celebrated, of course, the success of electromagnetism as if it's the foundation for string theory, but it's completely different. Because string theory talks about extra dimensions, talks about speculative ideas that we don't know exist, right? And then the question is, how do we make progress? It's by experimentation, testing them. But the problem is, if you just do mathematical gymnastics, you don't make necessarily predictions, because it turns out there are many versions of string theory. We don't know which one is the correct one. And moreover, you can't say much about what happened before the Big Bang, what happens inside a black hole. So it's like having a plumber come to your home and you say, can you fix the toilet? And he says, sorry, it's too complicated. Can you fix my faucet? No, it's too complicated. But he tells you, but if you go to the metaverse, there I'm a super plumber, and it's in extra dimensions. I can actually solve the problems in all plumbing problems in 11 dimensions. I can do that for you. And what would you do? You would say, okay, well, thank you so much. And that's the situation we're at right now with string theory that was promised to be the theory of everything. Turns out that it's the theory of nothing, because we can't really use it to make predictions about how to unify quantum mechanics and gravity. Now, my point is, this was sold by Brian Greene as the foundation of the frontiers of physics for decades. And so you have these science influencers. Now, Brian was actually doing some research during...
Which one of them?
Brian Greene was doing some research during these years, but others like Neil deGrasse Tyson, he didn't publish a single scientific paper within the past 2 decades.
Of course,
And my point is, if you are sitting on the bench and describing what happens in the soccer field, let's say right now it's the World Cup, so it's very timely. Lots of people are sitting on the, looking at the game. You can describe it and become popular, right? That's no problem. But the one thing you cannot do is score a goal, because you are sitting on the bench. So an influencer is different. I mean, if you want to tell the difference between a Kardashian of science and a practitioner of science, it's the fact that a practitioner of science can make a discovery.
Yeah, and he's on the field.
And moreover, another distinguishing signature, before that practitioners make the discovery, before he scores a goal or she scores a goal, before that, how would you be able to tell that they are practitioners? By the fact that they're not trying to be popular. Because sometimes they pay attention to evidence that nobody else pays attention. In the early days of any breakthrough, you have people who work on something that nobody else appreciates. And once they make the discovery, of course, everyone says it's obvious. But before that, they are not popular. So if you see someone who is always popular, that means they're always flowing with the wind. They can write a book that is called Take Me to Your Leader. When UAP, this UFO subject, becomes popular, they will write about it. Why? Because it's popular. While 5 years earlier, they would ridicule it, decline to talk about it. That's the signature of an influencer, because an influencer always wants to be liked, always wants to be popular. So when the narrative changes, they change their tune. But they cannot be the agent that brings the change.
I don't know if there is a place in popular, popular culture, for these matters, for people who will give the public the science in a more.
I mean, there are servers in restaurants, right? What do? They don't cook the food; they just bring the food to the
commentators in soccer.
It's completely legitimate, but they should not be the authority. That's my point.
My question that I want to go in which is quite a bit different direction, which is, if you add to Stillman their case for against your approach, what would it be? And
it would be very simple. They would say, first, it's not popular within the mainstream. Second, for a good reason, they would say, because there is no clear evidence. My answer to that is that if the mainstream is not willing to engage in studying this subject, there will not be evidence, right? So it requires a lot of effort from people like myself to get private funding, either from foundations or from individuals, so that I can support a program called the Galileo Project, where we collect new data. We have 3 observatories. The latest one is in Las Vegas. And that came about, just to give an example, I gave a TED Talk 2 years ago, and the owner of the Madison Square Garden and the owner of Sphere in Las Vegas, his name is Jim Dolan. He saw my talk and called me and said he watched it twice and said,
it was amazing.
Could I meet with you? And I said, sure. And then within a week, he showed up with his bodyguards at my home, and we had the conversation, and he asked me whether I'm willing to put an observatory of the Galileo Project on top of Sphere. And I said, sure. And with him was Jane Rosenthal, who is she is the director of Tribeca, the executive director. So, so these are the kinds of supporters that I get. There were a number of billionaires visiting me and supporting. But my point is, the mainstream of science is still reluctant to address the collection of data. Now, it may well be, and that's my other role right now, that we get high quality data from government, because they invested in a lot of sensors and they might find the evidence that we are seeking. But in parallel to them, I have the Galileo Project, observing the sky, looking for objects that move outside the performance envelope of human-made technologies, okay?
Yeah.
And so my point is, I wish that this was a mainstream subject within physics, because then if you search for a decade for those things and collect data and you don't find anything, then you can say, there is no evidence. But without doing this work, how can you say that? Now, at the same time, the mainstream of science was looking for weakly interacting massive particles as dark matter. We haven't found anything. So if we were to invest billions of dollars, like we did in the case of dark matter, towards the study of UAPs, okay? If we just did the same and didn't find anything, we would be at the same place as the mainstream community is right now with respect to the nature of dark matter. They did the investment, put a lot of time, research time, didn't find anything. In the case of UAPs, they didn't put the time or the money, and they claim there is no evidence. Obviously, it's because nobody did that seriously. So that's the way I see it. And, like anything in science, early on, the evidence is unclear. It's just anomalies that flag new knowledge.
Yeah.
And you have to pay attention to anomalies. You can't ridicule them. And that's true also of interstellar objects, another subject that I work on. And I'm basically anomaly seeking. I'm just looking for things that do not line up with what we already know as a signature of more studies, so that we can get good enough data. Because if we have a high resolution image of a spacecraft and it's not human-made, then we will know for sure. And in order to get that, we need to be curious. We need to be intrigued by the anomalies that at first are not conclusive, but once you get into it and you study these objects, you will find that they are conclusive.
Yeah, I'm sorry for being the devil's advocate in this matter,
go ahead.
But just for discussion purposes.
Yeah.
So,
and by the way, I should say, in the committee, I forgot to mention,
Yeah.
I also selected a skeptic, and I was attacked for that. And I said, I disagree with this skeptic. In fact, I have a bet with him that he's wrong, that by 2030, there will be clear evidence that we are visited by extraterrestrial technological
By 2030?
artifact. Yeah.
Wow.
And I had a bet with him, but I also wanted him to be in the committee. And you might ask why. First of all, to avoid any biases in the way we deliberate. If we are forgetting some important argument, he will bring it up. Secondly, if we get convinced that there is indeed something unusual, and he is convinced of that, and he started in a completely different opinion, then I know that we did something right, because he agrees with that. And of course, he also represents a community of people, so they need a representation in the committee. So I included him. I thought that's a good choice. But immediately I was attacked by people who already know the answer. And by the way, I'm completely resilient to these attacks, because I get attacked from both sides of the spectrum. I get attacked by mainstream scientists who don't want to hear about these things. And I get attacked by believers who know already the answer. And, that's the only way for me to do the right thing.
Yeah. So in relation to that, there was this Nature article, right, which was very, made a lot of noise around you, and it was about this summit. That people said they begged to differ was like the
About Oumuamua?
about it was about the Delian debris.
Oh,
Yeah. I think this one is just a good example of you can say close-minded the scientific community.
I should say about this one.
Yeah, but if you can also give like the reason for the criticism in a light-hearted manner.
Yeah, so we're dealing with the interstellar meteor that we went after, and we collected 850 molten fragments, meteoritic material from the ocean floor that is about 2 kilometers deep outside the territorial waters of Papua New Guinea.
Mm-hmm.
And we brought it for examination in the laboratory of my colleague Stein Jacobson at Harvard. And at first, we realized that 10% of those fragments have a composition that was never reported in the scientific literature. It's different from what you find on Earth, Mars, the Moon, and any other solar system object so far. And we said this unusual chemical composition that has some elements elevated by a factor of 1,000 relative to the solar system composition. Elements like beryllium, lanthanum, uranium, we call it the Belau chemical composition. This may be an indication that we recovered material from outside the solar system associated with the interstellar meteor because we went to that site. And we were attacked, and in particular, we were told, these could be just fragments of material from Earth or human-made coal ash. We checked it. It took us several months, and we demonstrated beyond any doubt that it's not any of those. And then we were told that we went to the wrong place, or that you can't believe the U.S. government data. Or that, this may be from some unusual part of the solar system. So there is a new paper that we just completed. I cannot give a lot of details because it's now being still refereed. But it gives clear evidence that we're dealing with materials from outside the solar system.
Wow, this is...
And I will give more details as soon as the paper is accepted for publication.
I would love to see it.
So this took us 3 years, of course, to do the analysis. But that's the way science is done. And what I'm trying to say is a lot of people are eager to destroy. Now, to destroy a scientific argument, a scientific endeavor, this was a lot of work for me to, first of all, write the original paper that we're dealing with an interstellar meteor because we had to get confirmation from the US government. And I reached out through the White House to the US Space Command. They wrote a letter to NASA saying, we checked the data and at the 99.999% confidence it's interstellar in origin. That was the first milestone because otherwise my paper with Amir Siraj, my student at the time, would not have been accepted for publication. But even after, when we went to the Pacific Ocean and I had to organize a whole team and get the funding of $1.5 million, go on a boat. I've never been in the ocean, like that. Go on a boat for 2 weeks, sleep on the sofa of the conference room. And, we would bring things from the ocean, analyze them. So it was a lot of work. And then package this material, bring it back to Harvard, then find Stein Jacobson. That was not at all guaranteed that someone will be forthcoming to help with the analysis. He has the best instruments in the world. And eventually get some results that are interesting. Now, these people were sitting and looking at it and trying to find any possible reason for why it will not be viable. And what I find surprising is, why wouldn't they cheer? Why wouldn't they say, it's such a difficult task that you're doing.
Yeah.
So they should say, this is great. Let's give him a little bit credit. Let's wait until he delivers the results. Then we can argue with specific arguments or comments that he puts in the analysis paper. But that would be the generous way to respond, right? But instead they want to kill it. Why? Because
why are they reluctant to kill it?
Well, first of all, it represents new knowledge. So experts rely on past knowledge for their stature, because if someone else says, I discovered something that you haven't really explored in the past, and they are experts on meteors, let's say, they feel as if that something was taken from them, that their prestige was taken from them because they are representing expertise in this field.
So
and how dare someone else
to move the cheese, as you say?
Well, jealousy is the most important force in academia.
Wow,
so they are,
really?
Yeah, it is more than any other force.
Wow.
So they are just, since I did not belong to their club, they are reluctant from giving me the credit because they usually give each other credit within this, echo chamber that they built. And it's all tit for tat. Someone helps one person, the other person helps them. And in terms of papers but if someone else comes and says, you missed something important that was not yet explored, it makes them upset. There is also a cognitive dissonance. They are used to past knowledge. And if someone comes with a different perspective, it threatens their ego. There is this element in psychology, well known. It's called cognitive dissonance.
Yes,
that it shakes your belief system. So if someone says, I found an interstellar meteor, and you are used to just meteors being from the solar system, even though it sounds like a minor modification, like what's the difference? You say that there are rocks around the sun, there are rocks around other stars, and some of these rocks inevitably were kicked out of those systems, right? Because we see Oumuamua, we see Borisov, we see 3 Atlas. These are interstellar objects. So the only gap left is to say some of these smaller objects every now and then collide with the Earth. Smaller objects are more numerous. The chance of them colliding with Earth would be higher than the big ones. So anyway, it's not such a crazy idea. Yeah. But they want to be the ones to discover an interstellar meteor, and so they're upset that I come up. So then they would try to kill it. Now, the one thing, why are terrorists very effective? Because to build a building, to construct it, you need an architect. Then you need the builders, you need money. It takes a long amount of time. A lot of people are involved, and they carefully construct this building. To destroy a building, could be a matter of seconds because all you need to put is some TNT around it and explode it. It's much easier to destroy things than to build them. That's a fundamental fact about reality. And so that's the same. The same applies to scientific research programs.
I see where
and one more thing.
Yeah.
If you want to, the easiest criticism to make is to throw dust in the air and say, I cannot see anything. So there was a guy that said, oh, you found tektites, okay? And tektites are just glassy fragments formed when a meteor hits the ground. So then because of the heat, the ground, the soil, gets molten and takes part in this fireball that is created, and then you end up with glassy pieces. The same happened in the atomic bomb test, that was done in near Los Alamos. They found it's called the Trinity, experiment. It was they gave it a name, Trinitite. They found these glassy fragments, and when a meteor hits the ground, there are these tektites. And so the claim was he wrote 2 papers saying, "Oh, what you find are tektites." Then it took us a year to analyze. We brought samples of tektites. We demonstrated beyond any doubt that they're very different than what we found. So it takes time to actually check those ideas, but you can look at the mechanism by, the way he operated, this guy, basically raise a lot of dust, say, oh, it could be this, it could be that, and then go to the press and say, oh, because of this and that, this should not be believed because there are these other possibilities. And of course, it takes time to check those other possibilities. So we not only have to analyze the original material, we have to then show that his ideas are wrong. And we demonstrated that. But after a year, then he comes up with another. So he basically throws things in the air and says, I can't see anything. But that's
muddying the water.
Or throwing dust in the air.
Yeah, I see.
The same thing.
But you said that the thing about the cognitive bias is and jealousy is the most strongest force in science, which is
in academia.
In academia.
It's even worse in the humanities.
Yeah. So I study a lot of organizations and nations and stuff like that. Our society organizes itself, and status quo and inertia is I think is the most strong.
So you find that in the astronomy community because there is a tendency to establish consensus. So if you look at the astronomy community, every decade, within the US, the National Academy of Sciences asks for a document that defines the priorities for the next decade. It's called the Decadal Survey. And you would say, that's amazing, that's a blessing. But in fact, what it means is that all astronomers come together to decide about the consensus view of what should be pursued.
Yeah.
And in the process of doing, that's a huge committee. And in the process of doing that, what you're doing is marginalizing innovation, because you decide that for the next decade or two, the entire community should invest more than $10 billion in the search for microbes by building the Habitable World Observatory. And that's a very appropriate thing to do, to pursue.
To inspire,
But at the same time, you sideline the search for technological signatures. And I say we should hedge our bets because they might be easier to find. So let's put comparable levels of funding. And the other argument is the implications for the future of humanity. If we find that we have a neighbor, cosmic neighbor, the implications would be huge. So you just multiply, even if you think the probability for finding it is small, you multiply a small probability by a huge impact on society. And then you realize, yes, we should fund that. Also, the interest of the public. There were 1 billion views of the website in the Pentagon, the Department of War, that released those documents about UAPs.
Yeah.
1 billion views within a few weeks.
Yeah,
Which other website has 1 billion views? I bet you if you write about microbes, it will not get 1 billion views even after you find them, right? So the point is that given the public investment, by paying taxes in science, we should listen to the public. We should also follow our curiosity. This is the biggest question that we can ask. And given the implications to the future of humanity, we should definitely explore it within the mainstream. It's a no-brainer, but it is being sidelined. Why? Because the community as a whole is driven towards a consensus view. And that's just like having a huge committee, as I said before. There is regression to the mean. With very little innovation when you have a big committee.
Yeah.
And I think a different mechanism for making decisions about funding in science should be to allocate a portion of the funding to innovation. Allow people to go in directions that are not the beaten path that everyone else wants to follow. Because if we all go in the same path, this may be a dead end, as happened with the Large Hadron Collider in the context of dark matter or supersymmetry. But if at the same time you explore other avenues, maybe someone else will make a big discovery that you haven't anticipated. And there are many examples of these situations, but they need to be funded in order for the efforts to be impactful. Otherwise, if it's based just on curiosity, it's not enough. Science needs to be funded.
Yeah, you touched on many things that I didn't even consider, which is amazing, and I really appreciate it. I want to, before we go further into other fields of scientific approach to the universe, I want to stay on the UAP assembly that you are
council,
that you are assembling. What is you said that it was 1 billion views when people in the website in regards to those documents. What of those documents you think is the most compelling thing? And there's some things that are released to the public before, because you had first person evidence,
right?
Which people they talked about themselves, seeing things.
Eyewitness testimonies, yes.
Yeah. What do you say about those?
Those were, some of those testimonies were quite unusual in the sense that they involved, for example, biological samples that potentially were retrieved by the US government in crash sites. And in particular, David Grusch said that he knows from interviewing 40 people within government about them, but he hasn't himself witnessed them. And we haven't seen the evidence. That's the main issue. So I had a Zoom call with him, and he was very sincere, and he definitely believes what he's saying. And he definitely spoke with people. The question is, can we see the evidence? Okay, because science is driven by evidence, by data. And, it's possible that someone misinformed him, within government, because they have a recovery of pilots that are humans. Like when they talk about Nordics, it's not extraterrestrials, it's actually people from a particular ethnic origin.
Yeah.
Stein Jacobson is from Norway, and he is a real Nordic. And he's very proud of the Vikings that were his ancestors. And he actually did a DNA test that indicates his heritage in that context. So I protected his legacy by saying, I don't think the Nordics are necessarily aliens. I think, well, at least he is not. He's definitely terrestrial. So the point is that there may be some confusion, misinformation that was somehow communicated because the US wanted to hide what it knows about adversarial nations. So if they retrieved technologies or pilots from crash sites and it happened to be classified, they gave it some code names. And maybe David Grusch saw those documents or heard people talk about it.
Yeah.
But but it's also possible that he tells the truth, and these things are held by corporations outside government.
But you said that you saw the Congress when they spoke there, and you said you didn't quite see it. It didn't convince you.
Well, no, I mean, it's not him. I'm convinced that he is sincere and telling what he thinks, but as we know from the legal system, people are often testifying under oath, and every now and then we have DNA tests that disproves their version. And so I want to see the DNA test, okay? I want to see the real evidence. Only then I will be convinced. I don't care about what people tell me. I really need to see the evidence as a scientist.
But what about David Fravor and
again, so there... Definitely, he noticed something unusual, but the question is whether it's human-made or not, these gadgets. And it could be potentially explained as a result of him not having the correct distance estimate. So these things were not necessarily moving very fast because he was moving relative to them, and perhaps he just didn't. So it could be, but we don't have the actual data. So that's, it would really help our council if we were to get access to real data and from multiple sensors, so we can figure out distances. But the other thing I wanted to mention is that the most convincing data that was released in the batches, and there will be more in the future, of course, is in the third batch of release, where there was a report from the director of the All Domain Anomaly Resolution Office, that included an event for 2 days in October 2023.
And the orange model.
Orbs. Yes, exactly. That split into smaller orbs. And so that, to me, was remarkable.
How come is it speaks more to your
because they have researchers in the All Domain Anomalies Resolution Office in the Pentagon. That's their goal. Basically, that's the task they're given, to figure out what these reports are all about. And they concluded, after looking at all the data, that we're dealing with, 40% of the phenomena that were reported are unexplained, unresolved. 40% is a big number.
It is,
for that event. And moreover, they reached the conclusion that it cannot be associated with U.S. technology or technology being employed, as far as we know, by adversarial nations. So to me, this explains why they're approaching scientists like myself for help, because they just cannot figure it out. Now, it's a puzzle. It's like a detective story, and I think we can get to the bottom of it once we get more data, gather more data. Many of these incidents take place near strategic assets, because that's where you have a lot of eyes on the sky and sensors detecting objects. So we don't know if it happens everywhere or just there, but it would be very natural for the Defense Department, the Department of War, to employ better sensors at those locations, just in case it's a national security threat. And if I manage to encourage them to collect more data just because of that, eventually we'll get to the bottom of it. So it will become absolutely clear if it's human-made or not human-made once you have good enough data. The only reason that we are still uncertain is because the data is not conclusive. So my point is, if it turns out to be human-made, I would feel that my time was not wasted, because I helped the Pentagon figure out a breach of national security. And as a citizen of the United States, I would feel good about it. It's not as if I was looking for weakly interacting massive particles for decades, which some scientists did, and not finding it. Then you say, okay, well, it didn't serve any person within society, right? Because you haven't found it, yet you put money and time into a direction that didn't lead anywhere. In the case of studying UAP, at the very least, I'm helping the Pentagon to do their mission. But so and then of course, if 1 out of a million objects turns out to be extraterrestrial, that would be the biggest discovery ever made by humanity.
Of course. I want to stay on the specific David Fravor story, because there were like 3 other pilots with him that's with their eyes saw the thing. I know we don't have the evidence, and I know I see the scientific approach, but for you as a human being, as a curious human being, doesn't it tell you that I can't see them all like making a coalition, a conspiracy?
Oh no. It's just that these objects behaved in ways that they are not familiar with. And the question is,
but it's way beyond our capacity.
No, because if, for example, just to give an example, suppose you drive on a highway and you see a black car in your rear view mirror, and then suddenly you see the black car in front of you, and you say, wow, that's amazing. This is an amazing engine that I've never seen before, because the car was moving at a fraction of a second across a very large distance. Turns out it's not the same car. If you don't have the license plate number, you won't be able to figure it out. There are many black cars. So just imagine a swarm of objects that come in and out of view, and then you see one and you see another, and you think, oh wow, it made such a huge distance over a short time. That's one example.
There's one video of them chasing it and seeing it from above.
That video in particular, it may well be that they misestimated the distance, because the camera was moving, and part of the motion of the object is a result of the motion of the plane, and so you have to know the distance in order to figure out if the velocity was unusual there.
David Fravor himself says that it was like for 1 second it was here and then it was there. He saw it.
But my point is, it may not be the same object. How do you know?
Oh, yeah.
If there is a group of such objects, so you might confuse one for another, just like in the example with the cars. So,
I see,
scientific research requires a lot of scrutiny, going through the data, making sure it's not just based on the impression you have. And
of course.
So it may well be that there was something really remarkable there, but we just don't have scientific quality data.
I understand. But okay, so I want...
And by the way, I should explain, this is not well understood by believers, because, for example, I'll give you 3 examples. There was a report from during the war in Ukraine that some astronomers in Ukraine saw unidentified objects, and they were moving at a speed of 10 kilometers per second, which, is like a speed that would generate a fireball. If any object that we know of moves that fast, there is no doubt that it would create a huge... Because in order for you to see it, and they reported they can see it with their telescope, it means that it interacts electromagnetically, and then it must interact with the air molecules. So then it would generate a fireball. There is no escape. If it interacts electromagnetically, how can you prevent the air from bumping into it? I mean, you can make it an aerodynamic structure, but still there is always some friction. There is always some cross-sectional area that, especially if it moves in different directions. So
so believers don't get it.
So but it remains dark. There was no fireball. And then I calculated that, they didn't have a good distance estimate. They just estimated distance based on the column of the atmosphere that they, the column of air molecules that they estimated from the optical properties of the object. But that was not robust. And I said, well, if they're wrong by a factor of 100 in distance, it could be bullets or artillery shells, and these are very common during a war in Ukraine, right? So you don't want to go to a military battlefield and say, I see objects and they must be alien objects.
But also if the country you're fighting against have this type of technology, it's alarming.
But I don't think the distance estimate was correct. And by the way, this region, this war, was monitored by a lot of satellites, right? So,
I see.
it's really difficult to imagine big objects not noticed by satellites moving in ways that are crazy. At any event, these astronomers claimed it, and I said, well, it could be a bullet much closer to them.
Of course.
And then, of course, the believers got really upset. Another example is the Apollo astronauts recorded flashes of light, blue light, in their Kodak film. And they were above the horizon of the moon. And I looked at the film record, and there were also blue dots in places that were not exposed to the camera mirror. So to me, it illustrated these are cosmic rays that penetrate through the camera and go everywhere within the film. So they were uniformly distributed in the film. So these are cosmic rays. These are not objects. People got upset. And I said, look, Artemis 2 just went there, went behind the moon, and the astronauts used the latest cameras and, took thousands of photos. And we didn't see any UFOs near the moon in their photos. The only thing they saw were 6 flashes from the impact of asteroids on the surface of the moon, which you expect. So I said, well, it's just cosmic rays, okay? And so people said, how dare you? You should apologize for bringing up cosmic rays. I said, I will not apologize because cosmic rays exist. If we shouldn't confuse cosmic rays for UFOs. Another example, there was a meteor that was recorded by a television crew in the Philippines coming behind a volcano. And then about 10 seconds afterwards, there was a white light emerging from behind the volcano going in the opposite direction. So people said, UFO, amazing. And I said, no, it's just a satellite. And because I calculated that given that there are more than 10,000 satellites around the Earth, and they move around the Earth every 90 minutes, so each of them goes 10 times around the Earth every day. Okay, so you calculate what's the chance that in a span of 10 seconds something will come in this way, and it's pretty large. It's substantial.
Course, yeah.
So I said it may be a satellite, and they say, how dare you say that? And I said, well, the fact that you don't like satellites will not make them go away because they're around. And and then someone said, oh, but it was above the clouds. And, if it was a satellite, it would have been hidden by the clouds. We wouldn't see it. So then I had to explain that this volcano is at an altitude of 2.5 kilometers. It's above the clouds. The actual volcano is above the clouds. So when you look at it from above the clouds, obviously you can see a satellite. So, these things, and the point is that that's the way science is done. And people get upset when you raise doubts in a belief, as if it's a religious belief. But I'm not saying, that God does not exist. I'm just saying there are cosmic rays and satellites. You must take them into account when you interpret things in the sky.
I even want to go further and say that I think it gives you credibility, and I think it perhaps the reason that you are now being the head of this committee, I think it's due to the fact that you are very scientific in your approach.
I mean, I made the same discussions also with people within government. They know me very well. And they say, here is someone that we can work with. It's not someone
just a believer.
Now, people say, what gave you this privilege? After all, you said that 3i Atlas may be technological. Well, of course, because in science, when you see anomalies, you are allowed to suggest possible hypotheses. So when 3i Atlas showed anomalies, I said maybe they are technological in origin. That's part of the scientific inquiry. That's my privilege as a scientist to bring those up. And then I encourage people to get more data, so if they want, they can rule it out. And it's the same as any other hypothesis, like the dark matter is made of weakly interacting massive particles. A lot of people said that. They were wrong. How come all these mobs on social media were not extremely upset and canceling all the physicists who said that dark matter may be weakly interacting massive particles? Because we know that they are wrong by doing the experiment. In my case, it's not at all clear because we still don't have full data on we don't have a close-up image of 3i Atlas. So it's legitimate as part of doing science to bring up possible interpretations for anomalies. You can argue with that and say no because of this and that. I think that you can explain these anomalies in a different way. That's legitimate. But the fact that I raise hypotheses should not be held against me.
Yeah.
And the fact that I bring up possible noise sources like satellites and cosmic rays should not be held against me, because the whole point about doing science is not to detect signals. There are lots of signals, but many of them are associated with noise, things that happen all the time, like satellites, like cosmic rays. This is noise. And the key of doing science right is to distinguish a signal from the noise, to say this is significant relative. Now, in the context of 3i Atlas, nobody argued with me that these are observed facts. The 3i Atlas arrived in the plane of the planets around the sun. That's a fact. It's not part of the noise. It cannot be noise. It's a signal that everyone knows about. I just give it a different interpretation. That's legitimate.
Are you saying it's not that at all? Now you know it?
No. So my point is, most recently, actually today, I finished with my student, Shokruz Kakaro, a new paper that talks about methane that was detected around 3i Atlas. The strange thing about the methane, and it was detected by the Webb telescope. Again, this is a signal, very high significance, no noise. Everyone agrees to that. It was celebrated by everyone. And we see methane only after 3i Atlas passed close to the sun, after perihelion. Why is that surprising? Why is that an anomaly? Because methane is more volatile than carbon dioxide, CO2.
Yeah.
And we saw carbon dioxide even when 3i Atlas was very far from the sun. As soon as it was discovered, back in August 2025, the Webb telescope, the same telescope that is detecting methane, detected carbon dioxide back 6 months earlier when it was a few times farther from the sun. But it didn't detect any methane back then. Methane is more volatile than carbon dioxide, so it can evaporate more easily when it is illuminated by sunlight. How come we didn't see methane, but we saw carbon dioxide, which is more difficult to evaporate? So the answer by the people who wrote this paper about the discovery of methane, and that's the first time methane is discovered around an interstellar object, the answer was, maybe methane on the surface was destroyed or evaporated long ago by cosmic rays hitting the surface. So there was a surface layer that was rich in carbon dioxide, but depleted in methane. So only after this outer layer was evaporated, as a result of the heating, the warming by sunlight, only after you remove this outer layer, you get to the deeper level where you find the methane close to the sun. That was the explanation. The problem is that there was also carbon monoxide detected very early, together with the carbon dioxide. The carbon monoxide is similar in its volatility to methane. So if methane was eliminated from the outer layer, how come carbon monoxide was still there to appear together with the carbon dioxide? So I wrote a paper saying, could it be a signature of life, a biosignature? Because in the case of exoplanets, methane is considered one of the most important biosignatures. It may be the first one to be discovered by the Habitable World Observatory.
Forgive my ignorance, but isn't methane in the same in oil in Earth?
Yeah, but methane on Earth is produced mainly by algae, and also bacteria, so it's produced by life. Otherwise, it's consumed. If there was no life on Earth, methane would be depleted significantly. So it's considered a signature of life if it comes together with oxygen, for example, reducing gases. So I asked, is methane around 3i Atlas a signature that there are microbes maybe in the iceberg, even if you believe it's an iceberg? Because then it may be a way of panspermia, transferring life between the source star of 3i Atlas and the solar system or anywhere else. This may be a way of transporting life between systems. So we did a calculation, and it turns out that there are some organisms that produce methane at a high enough rate in case there is a little bit of liquid water produced inside the iceberg as a result of some processes. You could get the amount of methane produced out of a small fraction of the total mass of 3i Atlas. So the idea would be that these microbes are being revived by the sunlight, and then they produce this methane. And immediately people started being upset about it because the argument was, yeah, but methane is also occurring naturally and it may be locked as ice. So I tried to explain, it's not just making general statements. You have to explain why methane appeared only close to the sun relative to carbon monoxide, carbon dioxide. Yeah. That's what people fail to recognize. They really want everything to conform to past knowledge. And clearly, 3i Atlas is delivering a message that is unusual. But even if the message is unusual, the experts are refusing to admit that it's unusual. They would find a way around it. Another thing that 3i Atlas has is 1,000 times higher deuterium abundance relative to the cosmic value. Deuterium is used as fuel for nuclear fusion, for example. So I did a simple calculation. I said, okay, Edward Teller, during the Manhattan Project, he asked the question of whether exploding a nuclear bomb would actually ignite the atmosphere or the oceans as a result of chain reaction. Yeah. In the oceans, the issue was whether it will ignite the deuterium, which is very low abundance. And Hans Bethe calculated, no, the radiative losses from the explosion would cool the material very fast, and therefore you would not get any chain reaction. So indeed, they did the experiments, nothing happened. But on the other hand, if 3i Atlas has 1,000 times deuterium, Edward Teller also proposed deflecting objects like that are aiming towards Earth, deflecting them by exploding a gigaton equivalent mass of TNT next to them by a giant nuclear bomb. So he thought about that as a way of deflecting objects, that just exploding a gigantic nuclear bomb next to them and kicking them. So I asked,
fascinating. Wow.
So I did a simple calculation, tried to figure out if we were to explode that next to 3i Atlas, given the high deuterium abundance, the same as Edward Teller originally worried about in the context of the Earth, whether that would ignite 3i Atlas, the deuterium in 3i Atlas, and create a chain reaction that would make a huge atomic explosion next to Earth. The answer is no, it misses by a few orders of magnitude. It will not ignite, even though the abundance of deuterium is 1,000 times bigger than the cosmic value. Wow. We are safe. But I wouldn't recommend exploding a giant nuclear bomb because of other reasons. Yeah.
Wow. Okay. So first of all, I hope we will get to everything because this is so fascinating and going through. I hope we will. But I just want to say, because we going around it many times, I think I want to say that I think it's noble and courageous of you to keep suggesting hypotheses in the, with how people treating them.
By the way, Albert Einstein said, imagination is more important than knowledge.
Yeah, of course.
And he said that for this reason, that without imagining things, we will not explore the unknown. We would think that we know everything.
Yeah. Yeah. Amazing. So I want to dive into a big subject. We talked about it several times during the conversation, but the vastness of the universe, and if we can go back to the Big Bang, and what do you think, when you explaining perhaps the Big Bang theory, what would you say is the cause of it? And if there are any, religious people listening to us, which I bet there are, how come you bypass the God explanation?
Yeah. So my favorite toy model, which is not at all embraced by anyone else, is that once we develop an intelligent civilization like ours, let's say, 1 million years after they discovered quantum mechanics, they have at last, it's not string theory, but they have a different theory that unifies quantum mechanics and gravity. And then they realize what happened before the Big Bang, because right now we can't extrapolate beyond the Big Bang because Einstein's theory breaks down. We don't have a quantum theory that will give us a prediction, but let's say in 1 million years we might. So just think about such a civilization. It has a recipe for how to create a baby universe, because it's just like a recipe for a cake. If you have the ingredients and you have the oven to put them together, you will end up with a cake of a particular type. So if we understood what were the conditions that led to the Big Bang before the Big Bang, then we would know what's needed to make a universe like ourselves, like ours.
Yeah.
And that is a very dangerous knowledge in principle, or not dangerous, but the biggest knowledge you can imagine having, because if you can generate those conditions in the laboratory, you will be able to create a baby universe. So,
isn't digitally creating it is perhaps even a
oh no, so it's not fiction, it's reality. So you just need to focus a large enough amount of energy in a small enough volume of space such that you create the conditions leading to the Big Bang. I mean, very crudely, you would say you need to reach the Planck density of energy, meaning that's the highest energy density that we can imagine based on what we know about quantum mechanics and gravity. And so if you reach that density of energy density, you may actually naturally lead to a baby universe. It's very difficult to imagine an accelerator that will smash particles that create that. Otherwise, we would be able to test experimentally theories of quantum gravity. But my point is, maybe there would be some breakthrough that we are not recognizing now that would allow us to reach that point. And then, if that's the case, then it's just like generations of humans, okay, that each generation gives birth to the next generation. And so if within our universe there is a sufficiently advanced technological civilization, then after some time, it will reach the point where it can create a baby universe, and then we'll get a new branch out of it. And perhaps our universe is there are reasons why is it so symmetric. It's uniform, nearly uniform, and the same in all directions. Maybe that's the easiest one to produce. And also, if you can produce that, then out of it will come new civilizations that will create another Big Bang and so forth. So that is my idea, but it's not clear. I mean, and by the way, it's not the same as the simulation theory, because people confuse the two. The simulation theory says that reality that we perceive is not real. It's actually part of a simulation. I'm not saying that. I'm saying it's real. And within this reality that we live through, there are potential civilizations that have quantum gravity engineers that give birth to new universes, if it's possible.
I understand what you're saying, but and we will go into reality as a thing in a minute. But I get all the time the comments in my videos, and again, forgive me for my ignorance. I'm here talking to such a world-renowned scientist. People always comment on my videos when I talk about evolution that it's been debunked and there's no such thing. Many views. It's like a common thing. And I think that the Big Bang is more of an outrageous thought to consider.
It is. Einstein admitted that. He thought that it's more natural to have the universe forever, because otherwise what you should ask what preceded that Big Bang. And it's like the chicken and the egg problem.
Exactly,
what happened before chicken existed, and eggs existed, there was something else, right? So it's possible that our universe started from something else. It has to be, but eventually it ended up with these big bangs that came out of quantum gravity engineers. I wouldn't be surprised. Another possibility is, of course, these are possibilities people are discussing, that a collapsing, contracting universe reaches a point where the density of matter and radiation is large enough for it to bounce, and then you end up with a Big Bang, which then it's like a cycle. This is called a cyclic universe. But fundamentally, we just don't know what happened before. And of course, religious people say, we told you so in the Old Testament. We talked about a beginning in time. The question is, if there was a creator and it was not a quantum gravity engineer, if you call a quantum gravity engineer God, I'm okay with that. But if you want to say, no, there was a creator beyond everything we know about, then the question is, wasn't it boring for this creator before the Big Bang? Like there was nothing, and then why would it decide at some point to act and create what we have? Because whenever you act, it means that you're missing something, right? So if it's God, it has to have everything. It shouldn't be bored. By the way, God is also not definitely not a parent that can attend to one child. So
the other thing with it is, I don't know if you are aware to the depth of the Babylon story, the Tower of Babylon story, which sometimes being referred to as just the human arrogance.
And we see that today, of course.
And we see it today. Anytime we want to go above God as a civilization.
So obviously there are religious people, but there are also secular people in society.
Of course. Yeah.
And for the secular people, I would say Elon Musk is not the most accomplished space entrepreneur since the Big Bang. And if we meet aliens that are more advanced than we are, they will give us a sense of humility. So they will play the role of superhumans. Friedrich Nietzsche in 1882 argued that God is dead, and he advocated for a superhuman mentality.
Yeah.
But the point is...
And we don't have enough water to wash away all the blood, which is
my point is that if he was part of the council that I'm leading, Friedrich Nietzsche, and I would be happy to have him around, and we were to discover that there are non-human technologies that we found evidence for, and then he might realize that there is superhuman intelligence and entities that are not God. So when he said God is dead, he forgot about aliens.
Wow. But do you think that any type of uncontacted civilization out there, do you think they must be inside this universe, which includes the Big Bang in it?
Well, that has to do with the structure of space-time, right?
Yeah.
So the way we understand physics right now is that the speed of light is the speed limit. And unlike the speed limit on a highway that you can break, you cannot break the speed of light based on everything we know. Because that would immediately have consequences with causality. That you could go back in time and perhaps convince your parents not to give birth to yourself. So that's a contradiction. Anyway, according to physics as we know it, speed of light is the limit. And that means that since the Big Bang, there was a distance, a maximum distance that light traveled. That is our cosmic horizon. We don't know what's out beyond that. I mean, we have a hint because we see the radiation that came from the Big Bang. It's called the cosmic microwave background. The universe became transparent. It was hot early on, but became transparent 400,000 years after the Big Bang. So we see that radiation from 400,000 years after the Big Bang. It's like a photosphere surrounding us, like the photosphere of the sun. That's the region from where we see the radiation coming from the sun. The sun is much hotter in the interior, but we see only the outer part. And that's where the gas around the sun becomes transparent, so we can see the surface. And the same is true about the universe, except we're sitting inside of it. So we're seeing this surface of when the cosmic microwave background was last scattered 400,000 years after the Big Bang. We can't see what happened, in radiation. We can't see beyond that because
it's literally
it
the
was
event
opaque.
Horizon.
It was opaque. So it's the horizon of our observations with telescopes for light. But in principle, you can detect gravitational waves or neutrinos that can traverse matter much more easily, and so you can see them from earlier times. But we haven't done so. We haven't detected the cosmic neutrino background, the cosmic gravitational wave background. People are working on that. But the radiation that we see from that 400,000 years after the Big Bang, it seems to be uniform across the sky in all directions, the same, up to 1 part in 100,000. And the deviations from the brightness fluctuations are the seeds for the structures that we see the universe today. So there are small variations. The point is, given that the variations are very small, we can tell that the universe has the same conditions if you continue 4,000 times farther than the cosmic horizon. Because if there was a cliff that was closer than, let's say, 4,000 times the cosmic horizon, then we would notice it. The gravitational influence of it would be imprinted on the microwave background. So we can tell not only that the observable universe is pretty much uniform, but the same applies to a distance that is 4,000 times larger. And that's what we know. We don't know what happens beyond that. But within that region, everything seems to be very similar and well prepared and symmetric. And so that's remarkable. And the question is, what created those initial conditions and how, what was there before the beginning. And obviously there are lots of, planets, stars, potentially intelligent beings, not only within our cosmic horizon, but well beyond that. They have their own cosmic horizon. They don't know what we are doing. They can speculate.
Yeah. So this drives me into the subject of reality itself, which is, there's what came before, you said before with the chicken and egg, there's the observer and the and the thing you are observing. The universe itself.
Well, we are just spectators. We are players on the stage. Yeah.
Or perhaps everything that there is just consciousness. And
I don't think so.
You don't think so, yeah.
No, because you can, if it's consciousness, you can imagine that reality is much better than it is. You can imagine that you have $1 trillion in your bank account. That will give you pleasure. There is only one person that it's a reality for him, and that's Elon Musk. Right now, he's the first trillionaire. My point is, you can get pleasure from this thought, and you might want to believe it. But of course, you can check it by going to the bank and checking your amount of money, and you will realize that you don't have that. Now, so in my mind, there is a clear difference between imagined reality and the actual reality. Because
but how do you know that, excuse me for simplifying the conversation, but how do you know that you are not right now just in somewhere talking to a white wall and you don't know?
Because I haven't seen evidence for pixelization of reality the way you see in movies, or in fact, the best clocks that we have, see the time as continuum, not if you usually, these cameras that you are using right now, they have a frame rate. And if we were to examine the video that you're recording closely, we would realize that there are snapshots, one after the other, and they're separated by fixed amounts of time. And that means you are not taking an image in between these snapshots. So we haven't seen pixelization of reality in that way. We haven't seen in doing an experiment that we see reality at one time and only a fixed time later.
Of course.
So far, even the best clocks that go to a precision of 1 part in 10 to the 18, very precise. But they don't see.
Yeah, but of course, I'm talking to an imperial scientist, so there's the thing. But a thing that humbled me in this matter, which is light years difference between us. But I had a friend who became schizophrenic, and then I understood that the entire of my experience is just by
in your mind,
just in my mind.
But my point is that, of course, there are many people in mental institutions that believe that they are Napoleon, okay? There are many such people.
But he doesn't know.
And also, I should say, there are lots of people who take recreational drugs and feel better.
Of course.
Yeah. So, of course, if your objective is to feel good, you can believe in things and just enjoy that. But as a scientist, my obligation is to, I'm in love with reality. Now, what does that mean? It means that I will get more pleasure, let's say, from imagining a beautiful, let's say, woman that I can be in love with, and she would look fantastic. But then in reality, I see another woman that has, some scars, has some, she's not perfect.
Yeah.
You would think that I would prefer the imagined reality. But no, I prefer the real person because it's real. And I would like to know everything about all the faults of that person if I'm in love with her.
That's amazing. Yeah.
Because the true meaning of love, as far as I'm concerned, is to be interested also in the things that are not necessarily complementing.
Imperfections.
Exactly. Yeah. Because then that gives authenticity to the existence of the other. So to me, love represents trying to learn everything about the other side, even if it doesn't give you pleasure, because you're in love with that subject. And of course, I could get more pleasure from imagined things, but they would not be real and I would not enjoy them. So as a scientist, one way to think of me as a scientist is that I'm engaged in the act of love towards the physical reality. I want to know its limitations. If the speed of light is a limit, I want to know about it. I would not enjoy a Steven Spielberg film in which there is a violation of the speed of light. I would not enjoy it because even though it's more pleasurable, and obviously Spielberg wants to give red meat to the audience and make them happy, but that's not my objective. My objective is not to be happy. I'm in love with the actual thing that we live with, its limitation, with its constraints, even though Steven Spielberg finds it limiting to his script. That's what I'm interested in. Yeah. I'm interested in the limitations, in the things that make reality imperfect, but it makes it unique. It's one out of many possibilities that will give us more pleasure. But reality is under no contract to make us happy. And if you notice, people that you're attracted to are under no contract to make you happy.
Of course not, yeah. Wow, this is an amazing answer. And of course, it makes me feel dumb for even considering the other possibility, but but I am drawn to this, just as a philosophical practice. What I meant before is just my friend, the schizophrenic, he doesn't know it.
He doesn't know.
He doesn't know. So I don't know if I'm in the same condition
Well, you
as
should
him.
do the best you can.
Yeah.
So that's my point. We should do the best we can rather than... What happens on social media is very often people are just like getting addicted to drugs. They get addicted to ideas that make them happy.
Oh, I see.
Virtual realities.
Yeah. Okay, so we are approaching the end of our time nearly, but there are many other things that I was wishing to discuss. But let's. One thing that I'm really fascinated by, and I want to hear your take on it, is the radical transformation of our brain. In
with AI, you mean?
No, even before it, AI is another subject that I do want to address, but I mean the human brain had a leap, a jump when it's not specifically the human brain, but the evidence we see of early life
compared to other species on Earth, you mean?
On other species and on earlier humans.
Yeah. So one possibility that is not often discussed. I was asked by a student from France last week. He asked me, von Neumann came up with the idea of self-replicating probes. In other words, an advanced technological civilization will create probes that can go places, go to other planets, use the raw materials to produce copies of themselves and multiply. And then if you do the calculation, even if these probes are moving at a small fraction of the speed of light, let's say 1% of the speed of light, they would fill up the Milky Way galaxy within 100,000 years very quickly because they double in size, in number, every short amount of time.
Yeah.
So then he asked me, since we don't see any self-replicating probes around us, does it mean that there is no advanced technological civilization beyond our capabilities in the Milky Way galaxy? And I said to him, every day I interact with intelligent self-replicating probes. They're called humans. And of course, one possibility is that, we were created by some visitor. And we are the self-replicating probes that make use of the raw materials on Earth, and that this represents an advance even relative to AI made of silicon chips. So we are the robots made of chemical reactions using the raw materials on Earth. It's the best technology that you can imagine, better than silicon chips, because we haven't had robots that can repair themselves. A car that instead of just self-driving can also, if it gets a bump, can repair itself. It can consume dirt, from the earth and survive, So, and that's what biology gives you. And so that's a great technological advance. Maybe we exist as a result of another civilization. So that's why. So the question is whether we were produced by some synthetic biologist.
The question is, how did we get from a chimpanzee?
Yes.
Exactly.
So there were life forms on Earth, and maybe a visitor injected something that made them develop in the way we...
Do you really consider it as a science?
We need to explore this possibility. That was my answer to the student from France.
Yeah, this is fascinating. We are right now at 1.
Okay.
Do we have?
Yeah, just ask me.
Okay.
Yeah.
Okay. So the other things that I want to consider. First of all, if we
AI.
yeah, AI. Of course, I want to get in it. But the thing, if I may, to get to it in this matter, which is that the human brain, as you said, perhaps is developing the capability to become to create other sentient beings,
Right.
and perhaps artificial intelligence is
the next. Right.
So what do you think? Yeah.
Well, first, I'm worried about AI primarily because it makes humans that interact with it dumber. Because once you rely on AI, you're not exercising your brain as much, and it's just like taking a bus instead of walking to a destination. And when you have the option of using AI to answer questions, then you don't use your muscle in the brain. And I see a lot of students and postdocs that are losing their cognitive abilities. Now, they perform better than I would have imagined. They can write papers much quicker because the AI solves the problem for them. But I'm worried about the humans losing their ability. And also human-human interactions. I'm worried that those are deteriorating because many people who are addicted to using AI, they start to communicate with humans as if they are AI.
Yeah.
And that's unfortunate. Now, this is something that Martin Buber did not anticipate, the philosopher that lived a century ago.
Yeah.
He talked about human-object interactions, human-human interactions, and human-God interactions. But of course, he lived before the computer revolution. And now with AI, I think that changes everything because it changes the human-human interactions. The human-AI interaction changes the human-human interactions. And also, it changes the cognitive abilities. Because our brain is shaped by the dialogues we have. It doesn't matter with whom. So we can have a dialogue with other humans that will... And that's called education. If you have a teacher that gives you a better perspective, and so that's education. Your brain is being shaped by your dialogues with a more knowledgeable person. But if you are interacting mostly with AI, your brain will be shaped in a completely distorted way. And just to give you an example, yesterday I get a request from an investor in Europe, a very credible investor, and I thought, oh, great, another billionaire wants to fund my research, so I'll definitely have a Zoom call with him. And then I have a Zoom call, and this investor says, well, I have a new theory of space-time and quantum mechanics that I developed with the help of an AI agent. And I said, you're wasting my time. I don't have time for that, because advances in physics are supposed to be delivered in a different way. It's not a result of your interaction with AI. That will not bring the next breakthrough. And I just don't have time for that. I work so hard to write scientific papers that are being reviewed in journals. If you have a new idea, just go and publish it and then let people discuss it. But I don't have time to go over ideas that the AI, basically what the AI probably did was compliment this person and said, you're really smart, and then
it amplifies Dunning-Kruger effect.
Yeah, and it makes, what it showed me, demonstrated to me, is that even relatively rational people that are in charge of large investment firms, and this one is one of the most lucrative investment firms, they go crazy as a result of the AI bring them in directions that make no sense.
May I challenge this approach? Because first of all, the best example to give in the direction of your argument is Waze and maps. How we used to know where we're going, and now we don't know. Even when it's 6 minutes walk.
But my point is, you need to. It's not a substitute to you learning physics first, being aware of all the data first, and recognizing what was done for a century.
Of course.
You can't just come out of the financial industry and take a crash course for a month and use the AI agent to actually guide you into a new theory of physics, that is not the right approach.
Of course, yeah. And the thing I want to challenge is not this, because this I understand. Many people are perhaps thinking now that they
are Einstein.
Einstein.
Yeah.
Because it is...
Because of the AI.
It is providing you with compliments and stuff like that, just as you mentioned.
But progress in, by the way, just as a side note, progress in physics is very often driven by data, experimental data, because we realize something we haven't realized before. And that's why I pay attention to anomalies. So humans are often thinking, oh, we know everything, like the experts. They have past knowledge. If you were to find the next discovery based on past knowledge, you will not find it, because it's being driven by recognizing anomalies. And so my approach is not to ask the AI for insights. My approach is to ask nature for insights by looking for anomalies.
But this is the where I challenge it, because there was the same reaction when the computers were invented and the cars were invented.
Oh, sure.
It's just a tool.
As long as you treat it as a tool that helps you, but you already have the expertise of dealing with the subject matter, because otherwise you might think that it complements you and it basically echoes what was already done, or it gives you compliments, or it makes mistakes or hallucinations. Just yesterday I used the most advanced version of Claude to do some calculation for me, and it made a big mistake. I noticed it.
This happens all the time,
So the point is, mistakes happen, and the only way for you to recognize it is by you knowing how to do the craft that you're pursuing. And relying on it to advance you enough to be the next Einstein, I don't think it's a good idea. Now, in the context of mathematics, that's a different situation, because there the logic is well defined. And in principle, it could solve major problems in mathematics better than mathematicians. And there was a recent example in terms of one of Erdős theorems that was proven by AI. But again, it does make mistakes still.
Yeah, the thing I think is the most inspiring in this field is not perhaps becoming Einstein, but perhaps becoming more of like a Steve Jobs. I think more people will be able to create like $1 billion company.
Definitely.
You can do much more.
Yeah, but on that I would say a lot of technologists that advise politicians in Washington, D.C., a lot of them have a lot of money. And the one thing they're missing is they're watering the branches of the tree. They're allocating a lot of funding to AI, quantum computers. These are technologies. So it's like the branches of the tree of technology, but they're cutting the roots of science. So there is less funding for science. They don't understand the tree will not survive if you cut the roots and you water the branches. That will not save the tree. Because the advances today that they are using in the context of AI or information technology or quantum computers, those advances are thanks to curiosity-driven research that was done a century ago. And nobody back then saw the implications, the uses. And if you say it takes decades to benefit from basic science, that's true, but the point is, without it, you will not have the technologies of the future. So they lack the humility to recognize that and fund fundamental science. So there are lots of, the most successful technologies that are advising politicians to invest in technology, but cut science funding. And I think that's a dangerous mistake.
I think so too. Okay, so... I want to end things with coming back to the UAP committee, and I want to ask, what do you think? You said that by 2030 you made like a bet with the skeptic in your team.
Yes.
That by 2030 you will find the existence of alien life.
Because I'm an optimist, and I think that life very often is a self-fulfilling prophecy. Because if you tell yourself, many people just do not accomplish a lot as much as they want, because other people tell them you will never be successful, and they accept it. And then it's a self-fulfilling prophecy.
Yeah,
And the
of
same
course.
is true about the mainstream science that says, oh, there is nothing to be learned from UAPs. And this skeptic is adopting that approach. And I say, no, I want to invest in the search for evidence because they seem intriguing. And I believe that within a time frame of 5 years, we will find such evidence. So not only that I made this bet, but I brought this person into the committee so that he will admit and concede when the evidence is presented.
Yeah.
So, but if on the other hand, we will not find it, I will accept reality, whatever it is, and...
But what will be the strategy and what do you hope to find?
So I hope to, for example, if there is material from a crash site, I hope to see that here is a gadget or pieces of a gadget that were not manufactured by humans. That's amazing. Or if we have a high resolution image of such a thing, or if we see an interstellar object that behaves, propels itself in ways that we cannot understand, that doesn't look like a comet or an asteroid, the kind of iceberg or rock that we've seen before. To give you an example, astronomers, not only they argue that Oumuamua, the first interstellar object, was natural, they say it was a dark comet. That is the folklore among comet experts. What does it mean, a dark comet? It means an object that showed non-gravitational acceleration, but didn't show any evidence for a cometary tail, outgassing, that usually gives a push through the rocket effect to the object. So they call it a comet, but say that it's a dark comet where you don't see the outgassing. And then they went even farther and said, in the solar system, there are some dark comets. Let us give you some examples. One of them is called 1998 KY26. That was the name. And it's a dark comet because it shows non-gravitational acceleration. It's very fascinating because we can actually visit it and learn more about how the outgassing occurs. And so they said, great. And the Japanese Space Agency decided to visit it in July 2031 with a mission called Hayabusa 2. So they will land on it, trying to explore how it sheds mass in a way that we can't see and gets non-gravitational acceleration. They would study it. In preparation for that mission, last year, a team of astronomers observed the object with great, the best telescopes in the world with a lot of attention. And so they found that the object is roughly 10 meters in size, and it's quite shiny. It reflects half of the sunlight that is impinging on it. And then it also spins every 5 minutes. And that means that it's very sturdy, because if you had a rubble pile, some conglomerate of objects that are glued together by ice or something, it would break up if the rotation period is 5 minutes. And this one must be held together very well. So they said, very interesting. And now we know the size, we know it's shiny, we know it's spinning. We will definitely land on it and figure it out. And together with my team, we looked at the trajectory of this object, realized that it's very close to a failed Soviet mission called Phobos 1 to Mars. That's a mission that lost communication with the Soviets because one of the technicians sent the wrong command that had a semicolon, extra semicolon. So it lost communication because it was not locked on the sun and lost power in its solar panels. And then, we lost communication with it. So it's a failed mission. But it follows a very similar trajectory to this dark comet. And we explained that it could be that this dark comet, 1998 KY26, is the Phobos 1 Soviet mission, failed Soviet mission from 1988. And of course, the editors of the journal that we submitted it to were very reluctant to, they said the paper will not be considered for publication now, so we have to send it somewhere else. And what I'm saying is, we make a pretty good case that it follows the same trajectory. Mm-hmm. It has the right size. It's shiny, so just like you expect from a technological object. It's sturdy, as you expect from a technological object. What's the problem? We will land on it. And just imagine the Hayabusa 2 mission landing on it, and finding made in USSR on a label.
Yeah.
Wouldn't that be a teaching moment to all these comet experts? But moreover, our paper poses a hypothesis, an alternative interpretation that makes sense of an object that the community thinks is a dark comet, and we say it's actually Soviet spacecraft. Why not publish it? Because in July 2031, we will land on it and we can test if it's right or wrong. That's the way science is done. If you block the publication of this hypothesis, what good are you doing? We will land on it and find made in USSR, and only then you would say, oh yeah, it's actually the Soviet space. Like, why block an alternative interpretation? But it shows you how academia operates right now. And it also, I hope that once we land on it and it turns out to be a Soviet spacecraft, that all these comet experts that called it a dark comet would be more willing to consider Oumuamua as a technological relic rather than a dark comet.
Or as something that we will discover in the future.
Yeah, because they were wrong.
Yeah.
And they actually followed a mission to land on it. And if they were proven... But, my guess is, and we can meet again in 2031, if we find that this is a Soviet spacecraft, that all the comet experts would say, oh yeah, of course, in this case, this is obviously a possibility, but Oumuamua was definitely a dark comet still.
Yeah, this is how they do it. But, okay, last question, if I may.
Yeah.
Just, what does it say when the US government is doing the things and approaching you? What does it say about the relationship between specifically the field of extraterrestrial life exploration and the government relationship?
Yeah, so this is really interesting because first, science is not valued as much these days. It got a bad reputation during COVID because the advice, the medical advice did not hold to scrutiny. And it's really a surprise that government agencies approach scientists like myself and ask for cooperation. And I see that as a great privilege. Now, the other aspect, and by the way, I feel very good about it because there are lots of people on social media that are against this council because they know the answer already and we will not do anything useful. And to me, people who respond in this way, that they doubt the necessity for this kind of a council, they are actually anti-science. So this is a good litmus test because if you are curious about the nature of UAPs and you were trying for many years to argue that they might be technological and alien and so forth, you should be completely, you should celebrate the existence of this council, because what could be better than a bunch of scientists providing evidence beyond a reasonable doubt that this is the case? And if they don't get enough evidence, they will try to encourage government to get more. And so it only serves your purpose to, it's not going against you. And why would people be toxic and negative? And so it's just if they believe in something and they don't want it to be disproven using the method of science.
Yeah.
And that's unfortunate. That's a trait of humans. Again, we go back to this. People prefer reality to give them pleasure. Yeah. So I'm saying, okay, if you want to get pleasure, just go to Steven Spielberg's movie, okay? Go to movies, take recreational drugs, enjoy yourself. You can live your life this way. However, if you want to know more about the physical reality that we all share without any hallucinations, illusions, then you should celebrate science.
Wow. What an amazing sentence to end with. I have so many more questions, but we will end here because you are a very busy man. So thank you so much for your time, Professor. It was amazing. Thank you so much.
My pleasure.
Thank you.